Alright, today we're going to be talking about the atomic theory. Alright, so if you're new to this YouTube channel, I make short videos on different chemistry topics and also provide a free note sheet that I designed. I recommend you print these in color or you put them in a separate browser to take notes on your personal notes in addition to what I have written down. So with all that said, let's get started. So this is the notes, so if you want to screenshot it now, here's your time to do it. Okay, so atomic spectroscopy explained. So let's talk about this. And atoms absorb energy. Electrons are promoted to a higher energy level and they get what we call excited. And so when electron emits a photon of light, they emit a photon of light, when they return to ground state. So when they're jumping from high to low, you're emitting a photon of light. So kind of think of it like when you're going down the stairs. Every jump of the stair you go down, you're thinking of it like you're emitting something as you go from the top to the bottom on each of those stair levels. And so higher energy gives us a lower wavelength as well. So for hydrogen, we notice that the energy of the transition delta E must be equal to the energy of the photon emitted, but note that photon must have a positive, not negative energy, right? You can't have a negative amount of, photons released. That doesn't make much sense. So we have this equation here that relates it to hydrogen, and so we have delta E equals negative 2.18 times 10 to the negative 18th times 1 over NF2, which is the final energy level, minus 1 over I squared, which is the initial energy level. And that'll be useful in some calculations that we're going to do. So another thing is that we have the connection between the energy of the electron and the energy of a photon. As stated before, the photon has to have positive values. So what we're going to do, the delta E of the electron, it could be positive or negative, but just to be safe, we're going to always take the absolute value of it. So we're going to, of course, and always get a positive energy of the photon. So let's do one question. It says calculate the delta E of the electron of a hydrogen atom as the electron drops from the n equals 5 state to the n equals 3 state. You can pause it or you can see what I have done. Okay, so our answer is negative 1.55 times 10 to the negative 19th, and I just used that simple equation that I highlighted in the previous slides. We put negative 2.18 times 10 to the negative 18th, also known as the Rydberg constant, divided by 1 over 3 squared, which was our final energy level, and minus 1 over 5 squared, which was our initial energy level. And notice I have a nice diagram here in the bottom. It kind of shows that this green arrow is when the blue ball goes from the top to the bottom, you're emitting something, and that is a high energy photon in which it's emitted. Kind of what I said about the staircase. When you're going down the stair, you're emitting something with each down staircase you're going. Okay, so that's it for this small slideshow. If you have any questions, please contact me. Email is in the slide, and also right here. Don't forget to subscribe and follow. I post daily, so turn on those post notifications, and don't forget to follow, like, comment, subscribe, and